Welcome to Phenom AI, your place to learn AI. Today, we're going to dive into one of the most important models in the history of natural language processing, BERT. Now, you've probably heard the name, but trust me, this isn't just another piece of tech jargon. This thing literally changed the game for how AI understands us, and today we're going to break down exactly what makes it so special. Okay, so let's start with the big picture. Think about it for a second. How does a machine really get what you're saying? I mean, truly understand it. The way you and I do, with all the nuance and the hidden meanings? For the longest time, this was the huge hurdle that AI researchers were desperately trying to get over.
And the main issue was something you could call the one-way street problem. The subtitle here says it all. Before BERT, AI really was reading with one eye closed. For years, these models processed language in a straight line, which, as you can probably guess, meant they were missing a whole lot of context.
So let's look at how we got there. You had your early models like RNNs and LSTMs, which literally process text one word at a time. Then the incredible transformer architecture came along in 2017. But even its first big star, GPT-1, was still working in one direction. They all read from left to right, which made them great at predicting the next word. But here's the thing. Predicting what comes next isn't the same as understanding the whole story, right? Not even close.
And that right there, that was the missing piece of the puzzle. True context. It's the ability to look at a single word and not just see what came before it, but also understand what comes after it. Because so much of a word's real meaning is shaped by its neighbors on both sides. Without that, you're just getting a tiny sliver of the picture.
But then, everything changed. Enter BERT. Developed by Google, the B in BERT stands for bidirectional, and that one word, my friends, was a complete and total game changer. For the first time, we had a model that could see the entire sentence all at once.
So what does that even mean, bidirectionality? Well, it's pretty much what it sounds like. Instead of just looking backward, the model looks forward at the same time. It looks left, it looks right, and it uses all of that information to figure out what a word actually means in that specific spot. It's like going from reading with one eye closed to finally opening both. Suddenly, you can see in 3D.
This is the classic example, and it is perfect. Take the word apple. If you say, I ate an apple, BERT looks around, sees the word ate, and thinks, okay, that's a fruit. Got it. But in the sentence Apple released a new iPhone, it sees released, an iPhone, and knows, we're talking about the company. See? Same word, totally different meanings, and BERT gets it because it can see the whole context. That right there is its superpower. Okay, this is a big one. BERT versus GPT. People get these mixed up all the time, and it's totally understandable since they both came from the transformer. But here's the key difference, the thing you really need to remember. It all comes down to understanding versus generating. And why are they so different? It's all about their architecture. You see, the original transformer had two main parts, an encoder, which is amazing at reading and understanding a big chunk of text, and a decoder, which is built for writing new text. BERT said, you know what? I just want the encoder part. Its whole job is to see everything at once and understand it deeply. GPT, on the other hand, is a decoder-only model. It's designed to only look at what came before so it can predict what should come next. So this table right here, this is the whole story in a nutshell. Just look down the columns. BERT's goal, to understand language. GPT's goal, to generate language. This leads to different architectures, encoder versus decoder, and different attention. BERT sees everything while GPT only looks back. And this all flows from how they're trained, which is exactly what we're going to talk about next.
I love this example because it just makes it so clear. Imagine the sentence, the cat sat on the mat. When BERT looks at the word sat, it sees the whole thing. It sees the cat before it and on the mat after it. Full context. But when GPT gets to the word sat, all it has seen so far is the cat. It has no clue what's coming next. That is the fundamental difference.
So you're probably wondering, how in the world does BERT learn to be so smart about context? Well, it's not magic. It's actually the result of two very clever games, or training tasks, that it's forced to play over and over and over again on a massive amount of text. The first and most famous one is called Masked Language Modeling, or MLM for short. Honestly, just think of it like a fill-in-the-blank test. You take a sentence, you randomly black out or mask about 15% of the words, and then BERT's only job is to guess what those missing words are. But to do that, it has to look at the words on both sides of the blank. It's forced to learn those bidirectional relationships. So simple, but so incredibly powerful.
But the creators of BERT were extra clever about this.
They knew that if they always used that special mask token, the model might get lazy and sort of cheat. So they came up with this 80-10-10 rule. 80% of the time, they use the mask token, but 10% of the time, they swap the missing word with a totally random word. And the other 10% of the time, they just leave the original word right there. This messes with the model in a good way, forcing it to learn a much deeper, more robust representation of the language.
Okay, so for any of this to work, BERT needs to know 3 things about every single word it sees. It combines these 3 pieces of info, called embeddings, into one big input. First, the token embedding, which asks, what is this word? Second, the segment embedding, which sentence is it in, sentence A or B? And third, the position embedding. Where is it in the sentence? The first word? The fifth? You put all 3 together and BERT has a super rich understanding of exactly what and where each word is.
All right, that second training game is called next sentence prediction. This one's pretty straightforward. The model gets 2 sentences, A and B, and it just has to predict, is sentence B the actual next sentence that came after A, or is it just some random sentence from the text? This is where those segment embeddings come in handy. Now, it's worth noting that later research found this task wasn't as critical as masked language modeling, but it was a key part of the original recipe.
Okay, so BERT has gone through all this crazy, intense training. It's played fill in the blank a billion times, and it now has this incredible, deep understanding of language. So what? What do we do with it? Well, this is where the magic really happens. We put its knowledge to work on real-world tasks.
The real power of BERT comes from a process called fine-tuning. Think of the pre-trained BERT as a brilliant graduate who knows everything about language in general. Now you want to hire them to be a movie critic. You don't have to teach them English all over again. You just give them a little bit of extra training specifically on movie reviews. That's fine-tuning. You take this universal language backbone and you quickly adapt it for a very specific job. It's amazingly efficient.
And this versatility is why BERT just exploded in popularity. You can fine-tune it for all sorts of things. Want to know if a product review is positive or negative? That's sentiment analysis. Need to sort articles into topics? Topic classification. Build a system that answers questions based on a paragraph? That's question answering. Or even pull out all the names of people and places in a document. Named entity recognition. In fact, this deep understanding is what led to one of the biggest updates to Google search in years, helping it understand what you really mean when you type something.
So if there's one thing you take away from all of this, let it be this. Before BERT, a word like apple had one fixed numerical representation. But BERT changed that. It creates contextual embeddings. This means the numerical code for apple in I ate an apple is completely different from the code for apple in Apple's new iPhone. The meaning is dynamic. It changes based on the words around it. That was the revolution.
BERT was a massive, massive leap forward. It taught machines to truly read and understand context in a way they never ever could before. But it also makes you think, right? What's next? If looking in both directions was the key to unlocking context, what's the next breakthrough going to be? How do we get to an AI that has genuine common sense, that understands cause and effect, and can reason on a truly human level? That's the next frontier.